what about like the different solids that they get the triangles set up, like from
How about I
6.2?
have, do you want it to be a complicated one or a straightforward one? Okay, which number was it? Number 11?
Oh,
Okay. All right, so if I did number 11, take the function y equals 1 over x squared minus 4, and I actually already told you what the derivatives were. I said, well, the derivative is negative 2x over x squared minus 4 squared, and the second derivative is equal to 6x squared plus 8 over x squared minus 4 cubed. And so you don't even have to take the derivatives for this one. I actually gave you the derivatives already. All right, let's see what we can do. So the first thing it wants to know is the domain, the symmetry, and the intercepts. I personally am not so worried about symmetry. We didn't really talk about it that much, and I feel like if you want to use symmetry, you can. I'm not that stressed about it. But domain is important. What is the domain of this function? Number 11 on the in-class handout that I gave last time. Does everybody have a copy of it, by the way? I've got some extras here.
Oops.
Can you read it? Yep.
Can you give me one? I'm not sure if I stopped or not.
These are the ones you passed out last time?
Yeah, before the test.
Oh, I don't think I. Which screen passed out?
You want to do me?
And with the
It's the same, it's 2 pages.
Oh, I have it.
oh,
It's 2 pages long, so you need more pages.
okay, sorry. The two.
Okay, so we're doing domain. How do you find the domain of our original function?
Negative 2 to negative 2 to the 2.
Right. The only two values that x can't be are going to be 2 and negative 2. Does that make sense? So the domain is going to go from negative infinity to negative 2, from 2 to 2, from 2 to infinity. So there's your domain. Okay. What about the intercepts? Right. How do you find the x-intercept?
So the original function equal to 0?
So the original function equal to 0 and solve for x. So 0 equals 1 over x squared minus 4. How do I solve that for x?
I would rewrite it and put the denominator in the numerator and just put it to a negative thing first of all.
Doesn't even matter. If you multiply both sides by x squared minus 4 so you don't have a denominator to worry about, you end up with 0 equals 1. Is that possible? That means 0 can't ever equal 1. So what does that mean in terms of x-intercepts?
They're on there.
There are none. Right. I have none for those x-intercepts. All right. What about the y-intercept? How do you find the y-intercept? That was how we just did this.
Plug 0 in for x squared.
Plug 0 in for x. You set x equal to 0, solve for y. So find the y-intercept. Y is 1 over 0 squared minus 4. The y-intercept is a negative 1/4. All right.
Oh, I'm sorry.
Yes.
You said find y-intercept that
X equal to 0, solve for y. And to find the x-intercept, you set y equal to 0, solve for x. All right. So let's talk about some asymptotes. Vertical asymptotes, horizontal asymptotes, and oblique asymptotes. Or you guys call them slant. I'm stuck a little too. All right. Do we have vertical asymptotes? Well, first of all, how do you decide if you might have vertical asymptotes or not?
if you have in your denominator 0.
Whenever you have a break in the domain, there's a potential for an asymptote. So where is there a break in the domain?
Negative 2 and 2.
Negative 2 and 2. Okay, so those are the possibilities. So to check, I want to take a look at the limit as x approaches negative 2 of my function. And I also want to take a look at the limit as x approaches positive 2 of my function. Now, as x approaches negative 2 or positive 2, I can't just plug those numbers in because that makes me divide by 0. 1 divided by 0 is, who knows if it's going to positive infinity or negative infinity. So what we need to do is, let's instead of taking a look at that limit, let's take a look at the limit from either the left or the right. Okay, so which way do you want to do it? The left or the right? The left? Okay, so numbers more negative negative than negative 2. Okay? So something slightly more smaller but more negative. So when I square that, is that going to be bigger than 4 or less than 4? Bigger than 4. Like negative 2.1 is more negative. Square it, that's more than 4. Right? So more than 4 minus 4 is
Very small.
very small positive number. Okay? So I get 1 over small positive number, which tells me that this limit is going to be positive infinity. Okay? So when the limit from one side is equal to an infinity, does that mean there's an asymptote? Yes. Okay, so I have a vertical asymptote at x equals negative 2. What about at x equals positive 2? Again, I need to take a limit from one side or from the other. Which side do we want to do? The left or the right? The right? Okay. I'm coming in from the right, those are numbers bigger than 2. Something bigger than 2 when I square it and subtract 4, it's still going to be a small positive number. So I'm going to get 1 over another small positive number. This tells me my limit is going to be positive infinity. So if the limit is infinity, again, that means I have another vertical asymptote at x equals positive 2. So I have 2 vertical asymptotes. What about, yeah?
Are you just gonna go on increasing and decreasing and concatenating to decide what they're doing on both sides of the asymptote and get
Yeah.
it on that?
Are you going to be grading our final exams?
Part of it. We team grade them, so everybody who teaches Coupling has a certain set of problems that they grade for everybody in every course.
You're more sensitive,
I don't know because I haven't seen the finals. You know, I'll do either the first third of the exam, the middle third of the exam, or the last third of the exam. I don't know which it will be. So, who knows? Okay, horizontal asymptote. How do you decide if you have a horizontal asymptote?
The ratio of the coefficients.
You take the
Numerator and
limit.
denominator.
You always start by taking the limit as x approaches infinity or negative infinity, either one. It's a polynomial, it doesn't matter which one. If it's not a polynomial, you have to look at them both. Okay. The limit as x goes to infinity of 1 over x squared minus 4. What's that limit going to be? 0. Why is this limit going to be 0?
Because, oh, sorry. Because the coefficient of, I'm sorry, the power of 1 is less than the power of x squared.
The degree in the numerator
Sorry,
is
yeah.
less than the degree in the
Yes, there you
denominator.
go.
So the limit is 0. If it's 0, what does that mean in terms of an asymptote? I have a horizontal asymptote at y equals 0. Do I have a slant asymptote?
No.
No. How do I know that I don't?
So the numerator is greater than the denominator.
That's when it happens, right? If you have a horizontal one, you don't have a slant one. As a general rule.
Didn't you, I don't know, wasn't there something else, other computation you had to make about it though? Or no?
If the numerator is a degree higher than the denominator, you have to do long division and divide it out. All right,
That's for slant.
that's for slant. Okay, so we've done our asymptotes now. So that was the next part. Intervals of increase, decrease, local max, local min. How am I going to figure those out? I need to use my first derivative. So they gave it to us. Had they not given us the first derivative, that's something we would have had to have figured out ourselves. Okay, but because we have the first derivative, where are my critical values?
Where f prime of x is 0.
It's exactly where the first derivative is 0 or undefined. So what values of x make it 0? 0 makes it 0. What makes it undefined? Negative 2 and positive 2. So using those critical values, I'm going to go ahead and draw a number line. We'll make this my f prime of x number line. I'm going to place each one of those critical values on the number line. So I've got negative 2x and x squared minus 4 squared. Negative 2x. Well, what's it going to be, positive or negative as I go across?
Okay, positive.
Positive, then
Negative.
positive still, then
Negative.
negative,